We have two equations here. We have x times y equals to k and x over y equals to k. Do not turn to the next page. Just look at the screen. Okay, so now one of them it's a direct variation and the other one it's inverse, not indirect, it's inverse variation. Okay, now let me explain to you what it means. Okay, and then you can make a decision. Direct variation means the x and the y, when x goes up, y would go up. If x goes down, y goes down. I think that makes very much sense, right? With the term direct variation. So they're changing directly with each other. And the other one, it's not indirect, it's called inverse because when x goes up, y would go down. And if x goes down, then y goes up. Now, that's one key thing that a lot of students tend to ignore, and that is the letter K right here. What's K? Usually, we say constant. So consider K as just a number. So now, I will give you 30 seconds. And think about this. All right? If K is a constant, and I need you to imagine if X is going to go up, and K is a constant, what would y do in order to, keep this constant relationship, okay? Okay, if x is going to change, what would y do in order to keep this constant relationship? So, all right, 30 seconds starting now. Think about it. All right, so how many of you think that x times y equals to k is a direct relationship or direct variation? Nobody. How about x over y equals to k is a direct variation? Okay, see some hands. All right. All right, now, I'm not sure if you remembered this. Did you remember this from Algebra 1? That you saw it vaguely, maybe? No? Yeah? How about in chemistry? We definitely, if you studied chemistry right here, we definitely went over this. Especially when we talk about gas laws. You remember P1 V1 is equal to P2 V2. When pressure goes up, volume goes down. Now, when we pose these questions to students, a lot of students would tend to answer the question here wrong, incorrectly, because when we think about x times y equals to k, a lot of people are tempted to say they are direct relationship or direct variation. They're tempted. They're tempted because they're not thinking. They're tempted to answer the wrong answer because, well, x times y seems very positive, and x over y, it looks evil. It's a division. Okay, so that's how they make up their mind. But if you think about this, if you say k, it's a number, say 100. Okay, well, what times what is 100? We can think about 1 times 100 is 100, right? 2 times 50 is 100. And then 4 times 25 is 100. And 5 times 20 is 100. And what you can see, what you can see is that as x increases, the y decreases. So that's how you collect your evidence and say, well, x times y, put the emotion away. It's not about its multiplication or division. It's just about, hey, if x is going up, the y has to go down in order to maintain a constant relationship. And same thing right here. Let's just say the k is a 2, for example. Well, I can have 2 over 1 equals to 2. Or I can have 4 over 2, 6 over 3, 10 over 5, yeah. Okay, I can keep going forever. And what you see is that when the numerator goes up, the denominator has to go up too. Now, if you are taking physics, this will be very, very useful. Okay. For example, in physics, who have taken physics already? All right, some of you. Now, for example, if you say F is equal to MA, for example, and I would say, what is the relationship between F and M, are they directly related or inversely related? Now, you gotta think. You gotta think, all right? You gotta think, all right? Assuming that A is not gonna change. So if mass goes up, how would F change? Would it go up or would it go down? It would go. Well, if somebody on the right-hand side is increasing, then something on the left-hand side must be increasing as well. So if M goes up, F goes up. In this case, this would be a direct relationship. Now, some of you might be thinking like, wait, hold on. It looks different though. This is a division. This is not division. Well, and this is my point here. It is not just about how it looks. It's about how you think. I can rearrange this into A equals to F over M. Well, now you have the division, but not, well, you're not going to see all these divisions all the time. Sometimes the equation is just like this, F is equal to MA, and you have to make a decision at the spot to tell whether it's directly or inversely related. Okay, so so you're going to see some variations of the expression, like for your notes here. You will see that it is y equals to kx. And the whole idea is that if x goes up, well, guess what? Y has to go up as well. Okay, so let's go ahead and take a look at a few examples.